Assalamualaikum and good morning to everyone. My name is Muhammad Nasri Bin Banchi. My registration number is 05DKA20F1068. My class is DKA2 as section 2. My lecturer is Sir Jeffrey Abad. I will talk about Newton method interactive graph. The function is the graph allows us to explore the concept of Newton method for finding the roots of equation. The aim is to start with an initial guess and get closer to the point where the graph crosses the x-axis. The result of applying Newton method appear to the right of the graph. When we can't go any further, there is no change to the accuracy of the route. We stop. We can choose 4 different functions and choose our own starting value for the algorithm. The heights of the vertical dashed lines are the function value at each point, and the solid segment are tangents to the curve at each point. The things to do. First function is fx equal to 2 square minus x minus 2. Try different positive and negative starting values and use the minus and plus buttons next to the slider to nudge close to the local minimum at 0 equal 0.025, x equal to 0.25. Second function, fx equal to 1 x square x. Once again, try different values for the starting point. We don't always get the closest root. Try starting near x times 1. Third function, fx equal to 3x3 minus 9 square plus f plus 5x plus 2. A cubic will generally have one local maximum and one local minimum, so investigate what happens if we choose values near those points. Fourth function, fx equal to x squared. In this case, we have a root which is also the minimum. Newton's method works best when the slope is a reasonable higher value near the root. But in this case, we can see that even after 12 steps, we are not very close to the root. In fact, this one very slowly converges, which means it keeps trying to find the root but never quite gets there in the reasonable number of steps. Graph applet. This is the example for the graph. Discussion. The above animation shows what's really going on in Newton method. Starting at the first guess we go upward until we hit the curve. The function value is, we find it's not 0 yet. We then travel down the tangent line back to the x value, so we can go up again to the curve to find the function value, and usually we hope it is closer to 0. We repeat the process until we get acceptable close to the root, usually by looking the whether the decimal places in the roots are still changing. The example used in this graph applet were first introduced on the preceding page. That's all from me. Thank you.